This is Kailash studying in AC department of third year. Now I would like to talk about the TikTok topic of subject high speed communications. And the course code of the subject is AECD 22. The topic is USB for equalization training sequences. This presentation dwells into the critical role of equalization training sequences in achieving reliable 80 GB per second speed in USB 4 Gen 4 links. Understanding these sequences is essential for robust, high-speed data transmission and ensuring seamless interoperability. This is the topic USB for equalization training and sequences. Moving on to the overview. The overview of USB 4 version 2.0 uses in a new era of connectivity supporting an impressive symmetric link of speed up to 80 gigabytes per second. The integrated process of bringing up a USB 4 link involves two keys, lane initialization and link training. This advanced capability is made possible through the sophisticated use of PAM2 and PAM3 signaling for data encoding, optimizing the bandwidth efficiency. And there are the four main topics in overview. Such first one is 80 gigabytes per symmetric speed. Means these are the pillars of the USB 4 Gen 4. The first describes about the unlocking unparalleled data transfer capabilities, and second is lane initialization, settling the foundation for link establishment, and the third one is link training, optimizing signal integrity for high speed, and the fourth one is PAM2 or PAM3 signaling, efficient data encoding for enhanced polarity. This is the overview of the USB 4 Gen 4. Moving on to next slide, we have about lane initialization phases. The journey to stable USB 4 link begins the meticulous lane initialization, progressing through several critical phases to establish optimal communication parameters. And the phase 1 describes about the cable capabilities detection, in which the initial step involves detecting crucial cables characteristics including Gen 4 support the presence of active cables, which are vital for extended reach and higher performance. The second one is phase 2, router detection. Following cable detection, the system identifies the router via the dedicated sideband channel, ensuring proper routing and connection management within the USB 4 fabric. And the third one is phase 3, link partner info and negotiation. The phase crucial for acquiring link partner information, negotiating the optimal speed, and deciding whether to operate in symmetric or asymmetric to adapting the diverse scenarios. These are the initialization phases 1, 2, and 3. And coming to lane initialization phases 4 and 5. The final stages of initialization focus on broadcasting negotiated parameters and fine-tuning transmitter, equalization for high-speed data integrity. Phase 4, broadcast and high-speed start. These negotiated parameters are broadcast across the link. Initiation of high-speed data transmission begins the laying the groundwork for full bandwidth utilization. Phase 5, TXFFE negotiation. Transmitter feed forward equalization negotiation takes place via the sideband channel. This critical step optimizes signal quality for both PAM2 and PAM3, signaling compensating for channel impairments. This is about the lane initialization phase 4 and phase 5, which are broadcast and high speed start, and transmitter feed forward equalization negotiation. Coming to Gen 4 training sequences overview. USB 4 Gen 4 employs a specialized set of training sequences TS1, 2, 3, and 4 to ensure optimal signal integrity and reliable high-speed data transfer. These sequences represent a significant evolution from traditional ordered sets, incorporating sophisticated header and pseudo-random elements. This involves TS1, 2, 3, and 4, in which first TS1 has PAM2 based for initialization equalization, and the second has for PAM3 for higher order signaling, and the fourth one has SSC and scrambler activation, and the fourth one is clock switching. This is about the training Gen 4 sequences. Now coming to purpose of each training sequence. Each training sequence in USB 4 Gen 4 plays a distinct and crucial role in optimizing the link for 80 gigabytes per second operation, addressing specific aspects of signal conditioning and integrity. Primarily focuses on transmitter equalization for PAM2 signaling, fine tuning, and the output signal to compensate for channel losses. And the second one extends the equalization process to PAM3 signaling, which is essential for higher achieving data rates by optimizing the more complex multi-level signals. And the third one is clock switching on retimers. Manages clock synchronization and switching for retimers, ensuring precise timing alignment across the data path for reliable transmission. And the last SSC and scrambler activation. This activates the SSC to run electromagnetic interference and enables the randomization, enhancing the signal integrity and independent errors are solved. This is about the purpose of each training sequence. Now moving on to transmitter equalization training. Transmitter equalization is a cornerstone of high-speed data transmission. With USB 4 version 2.0 leveraging an extensive range of TXFFE presents to fine-tune signal integrity. These presets are meticulously negotiated to optimize signal integrity, combating inter-symbol interference, and the sideband write streamline the equalization handshake and significantly reduced overhead. And the last one is USB 4 version 2.0 defines an impressive 42 presets which are phase of 0 to 41 for granular transmitter equalization, controlling for precise signal shaping. This is the usage of transmitter equalization and training. Now coming to receiver equalization and testing. Robust receiver equalization through testing are paramount for ensuring low errors at 80 gigabytes per second, even in the presence of challenging jitter frequencies. This is the graph which we can see by which describes about the receiver equalization through testing paramount for low error rate of 0 to 0.001, which are at 80 gigabytes per second. Now coming to transition to high-speed operation. Once the comprehensive training sequences are completed, the USB 4 link seamlessly transitions to its high-speed operational state, ready for robust data traffic. Following TS4, essential data integrity mechanisms like RSFEC encoding, precoding, and scrambling are fully enabled. Lane adapter transition into the CL state, signaling that the link is fully prepared for active data traffic. This meticulous process ensures robust error-corrected communication over the high-performance USB 4 links, guaranteeing data reliability. This is about the transition to high-speed orientation, which tells about the following TS4 essential data integrity mechanism, lane adapters into transitions, meticulous operation ensures robust and high performance of USB 4 links. This is about transition to high-speed operation. Now coming to the overall summary of the topic, importance of equalization training. Equalization training is the bedrock of USB 4's high-speed capabilities, ensuring reliable performance and seamless interoperability within the ecosystem, which enables 80 gigabytes per second, which is crucial for achieving reliable maximum data rates and optimizes performance, fine-tunes both transmitter and receiver for peak efficiency, and ensures interoperability, which is critical for device compatibility and compliance, by which user interface is not disturbed and the experience of the user is enhanced. And in order to upgrade also, the interpolation takes place and equalization training can also be changed, because in equalization training the bedrock of USB 4's high speed capabilities ensure reliable performance and seamless interoperability within the ecosystem. In the previous slide, we previously known about the graph when at 80 gigabytes per second, at which the 0 to 0.001 the graph shows the hike in which nothing is disturbed and the user interface is also good and no obstacles are takes place. Optimizes performance, fine tunes both transmitter and receiver for peak efficiency, critical for device compatibility and compliance, crucial for achieving reliable maximum data rates. So this is about the topic. Thank you.